we have this function f of x is equal to the square root of x. Is this a relation? Is this relation a function? What we can do is use a mapping. These values are the input, which are x, the domain, and these over here are f of x, which are the range. Now, remember that one-to-many mapping is not a function. It's like making an attempt to vote or voting twice in an election. You mapping to two candidates or more. That's election fraud, alright? So if I put in values in the domain, say 1, 4, and 9, and I say f of 1 is equal to the square root of 1. Square root of 1 is 1, so I map 1 onto 1. What about f of 4? F of 4 is the square root of 4, which is 2. Square root of 4 is 2. So 4 is mapped to 2, and f of 9 is equal to the square root of 9, which is 3. So 9 is mapped onto 3. But then the square root of 1 is a number that multiplies itself to give you 1. 1 times 1 is equal to 1. Okay, fair enough. But then we can say that negative 1 times negative 1 also gives you 1. So 1 is also mapped to negative 1. So here, the same argument applies to 4 and 9. 2 times 2 gives you 4, so 2 is the square root of 4, but negative 2 by negative 2 also gives you 4, so negative 2 is a value that you could map to. 3 times 3 gives you 9, so 3 is the square root of 9, but negative 3 by negative 3 also gives you 9, so negative 3 is also the square root of 9, so we have a one-to-many mapping. So this is not a function. Alright? Here, for what value of x is f of x undefined is 6 over x. Here, a function is undefined when you're trying to divide by 0. Right? It does not make sense. In reality, it's like you're here at, let's say you're here at 7 o'clock in the morning. You travel to another town that's 5 kilometers away, and you reach there at 7 o'clock in the morning, same day, same morning. The speed, your speed would be the distance traveled 5 kilometers divided by time. But if you leave here at 7 o'clock and you reach the other town at 7 o'clock, the time would be 0 hours. It's impossible to travel any distance in 0 time. So it is undefined. So in order to make this undefined, you have to make the denominator 0. The x must be 0. So x is equal to 0 when this is undefined. Alright? So once you make the denominator 0, the function is undefined. Here now, f of x is x plus 1, g of x is x plus 2. Find fg of x. Alright, let's go. So part A says fg of x. Fg of x. The thing is, if we have f of x, we say f of x is equal to x plus 1. But f of g of x, we have to remove g. We have to remove x and put g of x there instead. So here we remove the x and we have g of x there. But what is g of x? G of x is x plus 2. So instead of putting the g of x here, we put x plus 2. What is x plus 2 plus 1? It is x plus 3. Alright. So f(g) of x is x plus 3. Part B now. We have f of g, fg of 3. Fg of 3. The thing is, we already know that fg of x is x plus 3, so we can put fg of 3 there by substituting 3 for x. So it's 3 plus 3, which is 6. Alright. But then, another way of dealing with this is to say you want fg of 3. Now, f of x is x plus 1. You see it up here. But fg of 3, if you find g of 3 and put that in f, it's same as finding fg of 3. So let's find this. What is this? G of 3 is equal to, well, g of x is x plus 2, so g of 3 is 3 plus 2, which is 5. That's g of 3. Now, f of that, f of 5 is going to be, well, f of x is x plus 1, so f of 5 is 5 plus 1, which is 6. You get the same thing here. So that is another way of working it out. F of 5, g of 3, you have g of 3, which is 3 plus 2, which is 5. So when you find fg of 3, you're really finding f of 5, which is 5 plus 1. And that gives you the same 6 that you have here. Right? So fg of 3 is 6. Well, that's it for now.